Next topic is crystalline solid. Already in solid we studied solids classified into two types, crystalline and amorphous. And crystalline solid we will see in several types: ionic, covalent, molecular and metallic. We will see one by one because these are possible 3-mark question or 4-mark question. So important topic. So first topic we will see ionic solid. So what is ionic solid? Ionic solid means ions. It is due to ions present in the crystal lattice. Ions present in the crystal lattice. So ionic solid means ions present in the crystal lattice. Ions means it consists of both cation and anion. So in ionic solids, cations and anions are held together by strong force of attraction. Attraction already you know because of opposite signs. Cation means charge is plus, anion means minus. So in ionic solid, cations and anions are held together by strong force of attraction. To increase this, to increase the force of attraction, means positive ions surrounded by negative ions. So that means cations surrounded by anions. So suppose to increase the force of attraction, so cations are surrounded by anions and vice versa. Vice versa means anions surrounded by cations. Because of the strong force of attraction, most of the ionic solids are in definite crystal structure. Important point, all the ionic solids are definite crystal structure. Why? Because of definite crystal structure means it is in cubic close packed arrangement. So ionic solids are definite crystal. Why it is definite crystal? Because cations and anions are held together by strong force of attraction. So suppose to increase the force of attraction means cations are surrounded by anions and vice versa. That means anions are surrounded by cations. So let's see one example. So example is NaCl. This is the NaCl structure. So in this NaCl structure, first one is, suppose it is sodium Na plus Cl. So one is sodium, another is chlorine. These cations and anions are held together by strong force of attraction. These atoms or ions are in the closely packed arrangement. That's why the sodium chloride crystals are cubic close packed arrangement. It is an example for ionic solid. So they will ask characteristics of ionic solid in 3-mark question. So these are all the characteristics of ionic solids. So first characteristic, it has high melting point. Why it has high melting point? Because ions are arranged in the closely packed, so it is a high melting point. The next important point, ionic solids act as insulator. That means do not conduct electricity, means insulator. Insulator in solid state. Act as insulator in solid state. Because ions are in the fixed position, so does not move. That's why ionic solids are act as insulator in solids. Suppose when we dissolve it in water, it acts as conductor. So when it dissolved in water, it acts as conductor. Because example already we seen NaCl. So in the solid, it acts as insulator. Suppose when dissolved in water, it splits up into Na plus and Cl minus. So in this case, it acts as conductor because ions are free to move from their position. So ions are free to move from the solution. That's why in solution, it acts as conductor. Final point, they are hot because ions are arranged in the closely packed, held together by strong force of attraction. Because of this, they are very hot. Suppose we need to remove the ions, means we have to apply some external force to change the position of the ions. So in the crystal, suppose, so we need to remove this Na plus position from this place to another place. We have to give external force. So that's why the 4th point I mentioned, they are hot as only strong external force can change the relative position of ions. It is an important 4-mark question or 3-mark question. So Important question. Maybe they will ask in the board exam. So this is about the ionic solid. Next one is covalent solid. Covalent solid means constituents. Already previous topic I mentioned. Constituents means maybe atom or ions or molecules. So constituents are held together by three-dimensional arrangement. 3D arrangement. Three-dimensional arrangement throughout the crystal. By important point covalent bond. So throughout the crystal by covalent bond. So covalent solid means ions are constituent means atoms or ions or molecules held together by 3D arrangement, three-dimensional arrangement throughout the crystal by covalent bond. So already familiar example you already studied in 10th standard, diamond. So diamond structure you know. So this one already you studied in 10th standard. So it is a three-dimensional arrangement of allotrope of carbon diamond. So in this covalent solid, constituents are together in 3D arrangement throughout the crystal by covalent bond. So what are all the characteristics? Suppose they will ask the character, they are very hot because they held together in three-dimensional arrangement, and it has high melting point. Which one? Covalent solids have high melting point. Covalent solids also act as insulator. They act as insulator and do not conduct heat or electricity. So this is about covalent solid. So our next topic is molecular solid. Molecular solid means it is possible in neutral molecule. It is possible in neutral molecule. So neutral molecules are held together by van der Waals force. Van der Waals force. What is van der Waals force? Means intermolecular force of attraction. That means between the ions. Intermolecular attraction or repulsion of intermolecular force. Intermolecular force between the ions. It is called as van der Waals force. So in this molecular solid, neutral molecules are held together by weak van der Waals force. So weak van der Waals force means attraction or repulsion of intermolecular force between the molecule, not an ion, between the molecules. It is generally all the molecular solid also act as, this molecular solids are soft and act as insulator. So already mentioned covalent solids also act as insulator. Covalent solids also insulator, high melting point, they are soft and act as insulator, molecular solid. So molecular solid classified into three types. So molecular solid classified into three types: non-polar molecular solid, polar molecular solid, and hydrogen bond. So non-polar molecular solid, polar molecular solid, hydrogen bond. Non-polar molecular solid meant the ions are held together by weak dispersion force. Weak dispersion force or important point London force. So London force means already mentioned in van der Waals force, attraction or repulsion between the repulsion of intermolecular force between the molecule. So London force means weak intermolecular force of attraction or repulsion between the molecule. So that's why it called as London force. So non-polar means ions are held, constituents are held together by weak dispersion force or London force. Second point, it has low melting point. Because of weak dispersion force, it has low melting point. Generally, non-polar solids are liquid or gas at room temperature. So example is naphthalene. So naphthalene used in household. So the factors. Next is polar covalent solid. In polar molecular solid, they are held, constituents are held together by dipole-dipole interaction. Constituents are held together by dipole-dipole interaction. So dipole-dipole interaction means plus minus. So dipole-dipole interaction. It has high melting point than non-polar covalent solid. It has high melting point than non-polar molecular solid. And important point, they are always exist in solids. In case of non-polar, liquid or gas at room temperature, it is in solid. So example is solid carbon dioxide and solid ammonia. Next is hydrogen bond. It is similarly constituents are held together by hydrogen bond. So this is for hydrogen bond molecular solid. It is due to hydrogen bond. These solids are always soft to solid. Sometimes they ask soft solids are which kind of molecular solid. It is an hydrogen bonded. Example it is an ice. Ice is an example for hydrogen molecular solid. So this is about the molecular solid classification. Sometimes they will ask London force, because last year half-yearly exam they asked, half-yearly or quarterly they will ask London force. So last one is metallic solid. In this metallic solid, suppose you take in a beaker consists of negative ion, C of mobile electrons. They mention C of mobile electrons. C of mobile electrons. Mobile electrons means minus E, negative charge, mobile electrons. In this, you add positive cation to this introduced into C of mobile electrons. Immediately, positive ions are moved towards negative ions. So, some vice versa. Similarly, negative ions are also moved towards positive ions. So, what is a metallic solid? Metallic solid means force that bind the metal ions within the sphere of influence. Within the sphere of influence is called as a metallic solid. Example: silver, copper, gold, zinc, etc. Somewhat it will go. So the normally they won't ask metallics, but suppose if they ask you, it is a definition in textbook, they give it in simple way. So concept is the force that bind the metal ion within the sphere of influence is called metallic solid. So these are about the crystalline solid classification. So from the four, maximum chances ionic solid, and ionic solid characteristics they will ask in 4 mark or 3 mark. Covalent solid 3 mark. Neutral molecular solid, suppose they ask write note on molecular solid, you mention neutral constituents are held together in a neutral molecule by weak van der Waals force. No need to write this definition, you just mention weak van der Waals force. Then these are all soft and act as insulator. So suppose they ask types of molecular solid, you write this 3: non-polar, polar and hydrogen bond. So next topic you will see the crystal lattice and unit cell.